We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello friends, myself, Rana from Mechanical Department of SNPIT and RC, UMRAKH, BARDOLI. Today, I will start the topic on measurement of the screw thread, and here in that we will see today the screw terminology and various elements of screw thread. Okay, so guys, first screw thread definition. A screw thread is the helical ridge produced by forming a continuous helical groove of uniform section on the external or internal surface of a cylinder or a cone. A screw thread, often shortened to thread, is a helical structure used to convert between rotational and linear movement of force. A screw thread formed on a cylinder is known as straight or parallel screw thread, while the one formed on a cone is known as a taper thread. Friends, you can see the figures of the external thread and internal thread. Here you can see this is the depth of the thread D. Okay, this is the highest top point of the external thread is known as the crest. The lowest point is called the root of the thread, and this is the cross. This angular side is called the flank, right? This is the nominal diameter. This is the pitch diameter, and this is the measure diameter. Okay, you can see here the value of pitch. The pitch means the distance between 2 consecutive threads is called the pitch, and this is called the thread angle, right? So here this figure is for external thread and this figure is for internal thread. Okay, next, what are the applications of the screw thread? Okay, so you can use in the fastening. We all know about that. The fasteners such as wood screws, machine screws, nuts and bolts, etc. The moving object linearly by converting rotary motion to linear motion as in the lead screw of a jack. So we have already seen the jack of the car, screw jack of the car. So the purpose of the screw jack is to pick up the four-wheeler or the vehicle up to certain height, right? So in that we are using the screw. Okay. So measuring by correlating linear motion to rotary motion and simultaneously amplifying it as in a micrometer. So you have used also a micrometer. So in that, what happened? The thimble and spindle motion. So spindle is rotary and thimble is rotary. So you can see the anvil is reciprocated forward and backward. Okay. So now these are types of thread. So according to the surface on which threads are cut. Okay. The first is external thread. A thread formed on outside of a workpiece is known as external thread. Examples like on bolts or studs, etc. A chamfer on the end of the screw thread makes it easier to engage the nut. Okay, so sometimes on the screw thread, on the screw edge, one chamfer is prepared to easier to engage the nut. An external thread is cut using a die or a lathe. Okay, so there is a figure of the external thread, or you can see the bolt. Okay, now internal thread. A thread formed on inside of a workpiece is known as internal thread. An internal thread is cut using a tap. So here you can see the figure of tap. This is the tap. Okay. So by rotating this tap, you can manufacture this kind of screw thread, internal thread. The internal thread is cut using a tap. Example on a nut or a female screw gauge. Okay. Now, according to the direction of rotation of the threaded cylinder, respect to engagement or disengagement with the other parts. Okay. So as per this criteria, we are having two types of thread. The one is right-handed thread and second is left-handed thread. Okay, right-handed, it means the nut must be turned in a right-handed direction to screw it on. Okay, so whenever you operate the screw or whenever you rotate the screw, whenever you operate the nut will be turned in the direction, right-handed direction to screw it on, and advances when turned clockwise. Okay, the thread are assumed right-handed unless specified otherwise. Right. The left-handed thread means a left-handed thread is one in which the nut would be screwed on by turning it to left. So advances when turned counterclockwise. Okay, so you can see the figure of the right-handed thread and left-handed thread. Here you can see turn clockwise. If you rotate the nut on the clockwise direction, the nut will forward in the or go into the screw thread. And if you go for the left-handed thread, the nut will turn anti-clockwise and the nut will go into the thread. Okay. So here also you can see the right-handed threading and left-handed thread. You can see the direction of the thread is reversed. Okay. Here also you can check the same thing, the left-handed and right-handed. Right. Now the third criteria is that according to the surface on which the threads are cut. Okay. So as per that, there are two kinds of thread: the single start thread and multiple start thread. Okay. Now single start thread, it means what? The single start thread consists of a single continuous helical groove for which the lead is equal to the pitch. It means whatever the pitch is there, that will be a lead of the screw thread. Okay. So as the depth of the thread depends on the pitch, greater the lead desired, greater will be the pitch, and hence smaller will be the core diameter, reducing the strength of the fastener. What it tells that if you increase the value of the pitch, the lead will increase in single start thread. Okay, and if the lead is increased, okay, then greater will be the pitch, and hence the smaller will be the core diameter. The diameter of the screw thread, core diameter of screw thread will be decreased and very smaller. So at that time, it will reduce the strength of the fastener. To overcome this drawback, multiple start thread are recommended. So that's why we are using multiple start. There is a reason. Okay. So now multi-start thread. In multi-start threads, lead may be increased by increasing the number of starts without increasing the pitch. It means there is a pitch value of 5 mm. So, and I want the value of lead is 15 mm. So there will be a 2 start will be there thread. Okay. So for a double start thread, lead is equal to twice the pitch, and for triple start thread, lead is equal to thrice the pitch. Right. In double start threads, two threads are cut separately, starting at points and diametrically opposite to each other. Okay, and multiple start threads are also used wherever quick action is desired, as in fountain pens, automobile starters, arbor spindles, hydraulic valves, spindles, etc. Okay, so let us see the figure of the single start thread and multiple start thread. So here you can see the single start thread valuation. Okay, this is the lead. Okay, lead means what? The in how many revolution the nut will turn. Okay, or for one revolution the nut will travel. How much distance nut will travel. So here you can see the L is equal to pitch in this single start method. Okay, so here you can see pitch value and this is the L value. These both are same. It means the revolution of the nut, one revolution of the nut, it is equal to pitch value and is equal to lead value. Okay. Now here you can see the lead value is 3 times of pitch. Lead value is 3 times of pitch. It means the pitch value is suppose 5 mm. Okay. So here it will be a 10 mm. It means the nut the nut will travel 10 mm in one revolution. That is the means. And in this case, nut is travel 5 mm in one revolution. This is a single start thread and this is a double start thread. Okay. Friends, here also the same figure is this, and this is a triple start thread. Here you can see this is a major diameter. Okay, and this is the pitch value. But here you can see the lead. There is a it's left 1, 2, and 3 thread. It means the revolution of the nut, one revolution of the nut is equal to 15 mm. Suppose pitch is equal to 5 mm, then lead is equal to 15 mm. Here also you can see this, the lead and pitch. Again, the pitch value is the same, but lead is different, means double started. Okay, and here you can see the pitch is same, but lead is a means four quadruple started. Okay, means 1, 2, 3, 4. Here is 1, 2. Here is 1, right? So in this case, nut will revolve one revolution, then nut will travel of pitch dimension means 5 mm. In this case, it will travel 10 mm. In this case, it will travel 20 mm. Okay, so this is called the single start thread and multiple start thread. Okay, now you can see the demonstration of the single start, double start, and four start. So here you can see the single start. Here you can double start. At a time of this, the nut will move or travel very fast compared to this. And here you can see nut will travel very fast. Suppose in case the pitch value is increased in this case, okay, so lead value is increased. Suppose pitch is equal to 15 mm, then lead should be equal to 15 mm. But in this case, if the pitch is equal to 15 mm, then this diameter of the core diameter is very less. At that time, the strength of the bolt is very big or reduced. Okay, so we can use double start or four start or multiple start thread at that time. Okay, so this is the difference between single start thread and multiple start thread, friends. Okay, so now this is the screw thread used. We all know about that things. The screw thread are used to hold parts together and act as a fastener like V thread, and to transmit the motion and power like square and Acme thread. Okay, so here the same figure is there. Now these are the types of screw thread, forms of screw thread. Here you can see the V thread. In this V thread, you can see the angle between the flanks are 60°. Okay. Here is the Whitford thread. Okay, BSW thread, British Standard Whitford thread. Okay. Here you can see the flank angle is, the angle between two flanks is 55°, right? And here the radius is applicable on the crest. There is 0.14 p. The all the valuation is respect to p, pitch value. This is a buttress thread. You can see the one direction motion. So here the angle between the flank and the surface is 45°. Okay. So here the pitch value is the same thing. Here the square thread is there. This is Acme thread. The angle between two flank is 29°, and is the warm thread. This angle between this angle is 29°. But difference is that in the 0.34 p and this is the 0.37. Okay. So these are the types of screw thread. Okay, so here there is a definition of the V thread, which is standard Whitford thread, buttress thread, square thread, Acme thread, and worm thread. Okay, so and this is the thread designation, right? So there are mainly two designations in the standard form. This is the British type designation, and that one is the metric type designation. Here you can see British type, there is 0.250-20 UNC-2A-LH. It means the major diameter. Okay, the A category is the major diameter in inch format. Okay, B category is that the threads per inch, 20 threads per inch means number of threads, and C locate the form means the shape of means unified national chords. Okay, unified national chords. D is the external thread. Okay, and D in this A is for the external thread and B is for the internal thread. You can apply. And E category is for the left-handed thread and R is for right-handed thread. Okay, so here you can see the metric time. So M20/2. It means the metric screw thread. X category is called metric screw thread. Y is the major diameter in mm, and Z is the pitch mm. Okay, so here you can say that the diameter pitch combination of an ISO metric screw thread is designated by the letter M. M is metric, followed by the value of the nominal diameter and pitch. The two values begin separated by the sign multiplied, means X. For example, a diameter pitch combination of nominal diameter 10 mm and pitch is 1.25 mm, which is designated as M10 by 1.25. It means metric form 10 mm major diameter and 1.25 mm is the pitch value. If there is no indication of pitch in the designation, it shall mean the coarse pitch. Okay. For example, M10 means that the nominal diameter of the thread is 10 mm and pitch is 1.5 mm. So, following are the other designations depending on the shape of the thread profile. SQ 40 by 10, it means the square thread of nominal diameter 40 mm and pitch 10 mm. Acme 40 by 8, it means acme thread of a nominal diameter 40 mm and pitch 8 mm. And worm 40 by 10, that is worm thread of a nominal diameter 40 mm and pitch 10 mm. So this is the thread designation of the screw. By this you can identify any kind of screw thread. Okay. This is the screw thread terminology, and this is for the external thread terminology, right? So here you can see the figure, and in this figure, uh, this is the axis of thread first of all. Okay, this portion is your major diameter, means at the top of the crest, and this called the minor diameter, that is at for the root. Okay, and this is your the pitch diameter from the pitch line distance. This surface is called the flank. Okay, this is the axial thickness. This is the axial thickness, right? Or we can say the collar thickness of the screw thread, right? And this is the flank angle, right? This is the addendum and this is the dedendum, right? And this is the crest value and this is the root value. And this is called the pitch. Okay. Friends, we will see in detail the screw thread terminology. Now first, pitch. We all know about that things. The distance from a point on a screw thread to a corresponding point on the next thread measured parallel to the axis. That is called the pitch. Lead. The distance a screw thread advances in one turn. For a single star thread, lead is equal to pitch that we have discussed earlier. And for double star thread, lead is equal to 2 times into pitch. And so on. For triple star, it will be lead is equal to 3 into pitch. Okay. Thread form. The cross section of the thread cut by a plane containing the axis, that is called the thread form. Major diameter. This is the diameter of an imaginary cylinder coaxial with a screw which just touches the crest of an external thread or roots of an internal thread. It is also called as nominal diameter. Okay. Minor diameter. This is the diameter of an imaginary cylinder coaxial with a screw which just touches the roots of an external thread or the crest of an internal thread. This is also referred as root or core diameter of the screw thread. Okay. Effective diameter, or we can say the pitch diameter. It is a very important term, effective diameter, because later we will find out the derivation of the effective diameter. It is the diameter of an imaginary cylinder coaxial with the axis of the thread and intersect the flanks of the thread such that the width of the threads and width of the spaces between threads are equal. Flank. It is a thread surface that connects crest with root. Next, depth of thread. It is the distance between crest and root measured perpendicular to axis of the screw. Okay. So this all terminology we have seen in the figure. The next terminology is angle of thread. This is the angle included between the sides of the thread measured in axial plane. That is called the angle of thread. Next is helix angle. The angle that the thread makes with plane perpendicular to thread axis. It is called the helix angle of that thread. Flank angle. It is half the include angle of the thread. Okay. And addendum. It is the distance between the crest and the pitch line measured perpendicular to axis of the screw. So it is the distance between the pitch line and the upper portion of the crest, that is called the addendum. Dedendum is the distance between the pitch line and the root measured perpendicular to axis of the screw. It means the distance between the pitch line and bottom portion of the screw thread up to the root. It is called the dedendum. Okay. So here we will see the measurement of various elements of thread. Okay. So now we have already discussed the screw terminology. Okay, the major diameter, what is minor diameter, what is effective diameter, what is pitch, what is thread angle. Now this is the method to measure the various elements of thread. Okay, so for the screw thread, it will be necessary to measure the following: that the major diameter first, then minor diameter, then effective diameter, then pitch, and then thread angle. So today we will see how to measure the major diameter. Now, first with the help of the ordinary micrometer. Okay. So here the ordinary micrometer is quite suitable for measuring the external major diameter. It is first adjusted for appropriate cylinder size as having the same diameter approximately, and this process is known as gauge setting. It means in this practical we will use slip gauges, and the slip gauges having the same dimension will put into the micrometer, and I will note down the reading of the micrometer, and then I will apply my original screw which I am going to measure, that I will place in the screw thread micrometer gauge. Okay, and then I will notate R2 reading. Okay, and I will compare R1 and R2 both. Okay, so after taking this reading R1, the micrometer is set on the major diameter of the thread, and the new reading is R2. Okay, so here you can see the one measurement instrument, that is by which we can measure the major diameter. The instrument which are used to find the major diameter by the bench micrometer is called the fiducial bench micrometer. You can see the figure. In this figure, this is the measuring pressure gauge is there. There is a pressure indicator. This will indicate the pressure. Pressuring means pressure indicator. This is the micrometer drum. Okay, the accuracy of the micrometer is 0.001 mm. Right. The pointer must be in line when reading is taken. Okay, make sure this condition, that pointer must be line when reading is taken. Okay, so now let's see the how to measure with the bench micrometer. This is the figure of the bench micrometer exactly. Okay, but in fiducial bench micrometer we'll use only two anvil, right? So here I will keep this two anvil at my point. So I will prepare that what I will do first. I will do the place the slip gauges between two anvil. Okay, and I will set the indicator to the 0, right? Where it will be 0, then when it will be 0, then I will note down the micrometer reading, right? After that I will remove the slip gauge. Okay, and then I will put the original screw gauges through. Okay, then I will again rotate the micrometer and try to indicate the 0 dial over here, and then the time what is the micrometer reading, that I will note it R2, and then I will compare R1 and R2 both dimension. Okay, so this is the procedure. So first, for getting the greater accuracy, the bench micrometer is used for measuring the major diameter. In this process, the variation in measuring pressure, pitch errors are being neglected. The fiducial indicator is used to ensure all the measurements are made at same pressure. This is very important. The instrument, it has a micrometer head with a vernier scale to read the accuracy of 0.002 mm. Okay, the calibrated setting cylinder having the same diameter as the major diameter of the thread to be measured is used as setting standard. After setting the standard, the setting cylinder is held between the anvils and the reading is taken. You can see the fiducial indicator. There is a micrometer head. This is the measuring anvil, and this is the box. Okay. The cylinder is replaced by the threaded workpiece and the new reading is taken between these two anvils. Okay? So here, the major diameter from the experiment D is equal to S plus or minus R1 minus R2. So here S is equal to size of setting gauge, that is a slip gauge, and R1 that is equal to micrometer reading over setting gauges, and R2 is the micrometer reading over actual thread. Okay, so by comparing this R1 and R2, you can find out the value of major diameter capital D. Okay, so here by which you can measure the angle, sorry, major diameter of the screw thread. Okay, friends. So here we will stop today, and we will discuss the next topic in next lecture. Okay, thank you so much.